Hi everyone. Today we will just quickly go over all the 3D printed parts that you may or may not need. Well, some of them you have to have. Some are a must, and some are just good to have to make your installation or build easier, or just a little redesign from the original that people did, that people already built or modeled after putting together an SK tank. First one we'll go to is, yeah, I guess we'll just go over all the 3D print parts. All of mine are already printed. I used my Ender 3 printer to take care of that. So we'll just go one by one, and I'll show you uh, what a part is. So this is, there's a GitHub for SK Tank that already has all of these parts on there in STL and step files. So if you want to make modifications, you can download the step file and do the mods. First part we'll go over is the NEMA 8 gearbox bracket STL. So you need to print 3 of these brackets to hold the gearboxes. And let me just show you really quick what I mean by that. I'll show you the gearboxes. Whoa. So this here is the gearbox that SK Tank comes with. Well, it's a stepper motor gearbox combination. It is for moving the Z-axis, your bed up and down. And these are the 3 brackets you would need to print to hold the 3 stepper motor gearbox combinations. The bracket, as you can see, goes right around the gearbox, and this is how it mounts to the bottom of the frame. So I'll just show you the motor close up. I gotta figure out this focusing thing. It's fighting me. It's like it really doesn't want to focus. Jeez. Sometimes it does, sometimes it doesn't. So this is your gearbox. These are the 3D printed parts. I printed these 100% infill. Actually, it's for all the parts that are printed for this. They're PETG, and it's 100% infill for string. Yeah, it takes much longer, and they're pretty hefty. They weigh a lot. All right, next one. Next one, this is optional because you can just use zip ties. But these GT2 10mm XY belt clamps. And I have them right here. So these little, also 100% infill. These guys are, you're gonna loop your belt around through the bracket, through the aluminum bracket, and this will go over the belts and I'll clamp them together. You see that? And then you put 2 zip ties where these indentations are. You see these indentations right there? So it's gonna have loops, 2 zip ties to just hold the belt, well, hold the bracket from sliding up. But this bracket was what will keep the belts from going past each other. You can either do this, or you can just zip tie the belt. That's what I've done before, but since I have so much preparation time while waiting for the printer to ship, and then my build is relatively slow, I printed these. Alright, let's see what the next one is. This is a combination of two, right? It's an X end stop base and X end stop fingers. I ordered the aluminum gantry. I did not want to go with carbon fiber. I printed every single one of these fingers. The reason you print it is after you assemble it, there might be some play in your setup, and you need to have ability to adjust for that play. So these are all the little printed parts, and each plus or minus on it. So this is 2 millimeters plus, and as you can see, this one's minus. This is -2. And when we put them next to each other, you can see that they're basically completely opposite of each other. And this is X gantry mount. Right, so the bottom part will connect to the extra aluminum gantry. You can have your wire come up here, and then you have a location on the side here for mounting the optical sensor. And you see a little extruded area right here, extruded cut. That's because the sensor, the way it's mounted on the PCB board, it's through mount, so it's welded on the back side, so you gotta have a little bit of area for those soldered joints to go. Otherwise, the sensor would sit crookedly. So that's that. This one here is Seckit Tank Y-axis sensor mount. I decided to go with this upgraded version. It was created by Domus. It's 2 parts. It mounts to the frame, already pre-existing holes, and you can adjust the sensor up and down, in and out, and you just have to align it so that when the gantry is moving, or where the belts are going through on both ends, right? So that it basically uses part of the moving mechanism, and that's what is gonna check for Y positioning, which is fantastic, because there's gonna be less parts on that actual gantry, which will reduce a little bit of weight of the whole setup, which I think is a great add-on. When I saw that, I said yes, I'm definitely. Printed it in also PETG, 100% infill. So these are the 2 parts. They fit pretty tight. Almost, I think it's a little bit bigger than line-on-line fit. And you also have you see how there's a little relief, and that is also for that board, for the solder joints to sit in. And you see the slots, so you can move the sensor up and down, and you can move it in and out this way. So it's pretty good. Let me actually grab the sensor, and I can show you what I mean. What do I mean by all this? Okay. This is the sensor I'm talking about. You see how on the back side there's these solder joints? So when you put it in here, right, you need to have some of that space for the solder joints behind it. So you would mount this, you see how it moves up and down, and it goes the same way for this. Right, when I put it in, you see how it actually sits flat. which is what you want. If you have joints that are a little bit more than this, and you put it in and it's sitting cockeyed like this, you probably want to trim them. Another thing to watch out for, and I think I mentioned in my previous video, you see how cockeyed the sensor is? Right there. So before I install it, I'm gonna need to resolder this side of it right here and bring it back flat. So cover all that. The one we just spoke about, this one, what it replaces is this part right here, and I think one more part. I might just not have it. Oh yeah, I have it right here. I think it replaces either this one or this one. I have printed them before I found out about the Y. It's probably this. Actually, I don't really know 100%. And this one right here. This was actually it looked kind of funky, the way this mounts inside there. And you're gonna use one of the screws that holds linear rail block, and it would hold this part. I would rather just use a screw all the way, just by itself, to hold the linear rail block. Seems like that would be more robust. Okay, this right here, one lonely part. That's supposed to say up. Can you read that? Probably not. This holds your bed centered. So this is this joint where when the bullet sits in this joint, it is not gonna move, and the other two will move when the board expands. Pretty simple. Let's see how, if I have a, that's the one we just talked about. It's a fixed mount retainer, and you only need one of those. And then the last one is the one that I printed that goes inside the Y bridge. Whoa. There we go. Goes inside Y bridge. You can either print this right here, and you would put the nut in, insert it, screw it on, and then remove the holder. Or what I did is I made this plug that can just stay in the Y bracket. And hold the nut in place. So if you need to loosen it or tighten it a little more, you just put a hex key on it and you are good to go. That is all I really have for today. I'm getting ready to hopefully early next week to tighten the frame, and then I will start actually building the SK tank at a good pace. As you can see, all of the pulleys and everything is ready to go. Earlier today, I ordered the stepper motors from AliExpress that have an encoder in them, which makes it so that you cannot, it helps with skipped steps. So it's a closed loop system. If you don't know what that means, just Google it. Google stepper motor open versus closed system. Normally 3D printers use open stepper systems. There's no open loop. There's no loop technically. So your microprocessor just sends commands to move the stepper, and it doesn't know if the stepper actually moved that amount. So if the stepper hits something, not the stepper, while it's moving X or Y or Z, if it hits something, right, and it doesn't move, it has no idea. It's just gonna send it next command to move in the opposite direction or in the same direction. With a closed loop system, there's actually a microprocessor and an encoder that confirms. So when your control board sends a signal saying move 10 steps in clockwise direction, or degrees, however it works for steppers, it waits for those 10 degrees or steps to be counted, and when it sees that the motor moved in that direction, it will say, okay, good, next command. Another nice thing is, if you accidentally push it, it will return back to where it was supposed to be in, the position it's supposed to be in. So if it's supposed to be at 45 degrees and you lean on it and you push it to 55 degrees, it will move itself back to 45 degrees the second it can overcome your force. I've used closed loop stepper motors when I built 3-axis mill, and they're good, strong. There were much bigger motors on the mill, of course, but yeah, they were fantastic. I bought them from Steppers online, and they were great. So those should be in 2-3 weeks. By that point, I should be ready to just pop them in and move forward. That is all I really have for today. Please let me know what you think about this channel. Hopefully the sound quality is now better. I have this new microphone setup, wireless mic setup. I got all these new cameras, so the quality is supposed to be a little bit better, I hope. Now it's not really the quality I'm getting out of the computer, it's what YouTube does with it. So it's pretty funny. Let's see, did I get a text message? Nope. So that is it. You guys have a wonderful weekend. Good luck with your build as well. And leave comments with anything that I can improve on this channel. Bye.